depletion type MOSFET, a channel for conduction is already constructed physically. Due to this, current flows in between the source and drain without any gate bias voltage. This means that the channel conducts even when the voltage is zero. The MOSFET has the ability to group and both positive and negative gate potential. When the MOSFET is operated with zero gate voltage, it is said that the device is operating in E mode. In the depletion MOSFET, when the gate potential is made negative with respect to the substrate, it causes repulsion of negative charge carries out of the initially formed channel. This increases the channel resistance, which resultantly reduces the drain current. So, from the above discussion, we can conclude that in the depletion MOSFET, more negative gate voltage, the less the drain current that flows through the channel. In the case when the gate terminal is made positive with respect to the substrate, more number of electrons get ejected toward the channel, thus causing more current flow through the channel. The figure beside me shows the depletion type MOSFET. Okay, I'm going to explain you about the device configuration of depletion type MOSFET. The channel is made up of N-type material and substrate is P-type material. Through the metallic contact, the drain and the source terminals are connected to this N channel, and similarly the gate terminal is also connected to this metallic contact. If you observe here, there is no direct connection between this N channel and this gate terminal. The gate terminal is isolated from the channel using the Si02 layer. So, if you see the structure of this MOSFET, then it consists of metallic contact for this drain, gate and the source terminals, the insulating layer and the contacting, which is made up of the semiconductor material. That's why this MOSFET is known as metal oxide semiconductor field effect transistor. Due to this insulating layer, there will be no any flow of current through this gate terminal. The input impedance of this gate terminal is very high, and in fact it is even higher than the GFETs. The figure beside me shows the drain characteristic of NMOS. Increasing the magnitude of the negative bias switches reduces the number of free electrons in the N channel available, low conduction, and the drain current values as seen for VGS equals to -1 and -2 volt. As the gate to source voltage increases in the positive direction, the drain current rises faster as shown by the vertical spacing between the curves for VGS equals to 0 and the VGS equals to 1 volt. Just the 1 volt in changes VGS. Extending the drain characteristic to high values of VGS will encounter a breakdown region where the drain current rises quickly. The breakdown mechanism is avalanche effect in the space charge region at the drain end of the channel when the voltage drop across the region is substantial. Figure shows transfer curve for NMOS. Positive gate to source voltages enhance the number of free carriers in the channel compared to VGS 0 volt. The VGS 0 volt zone on the drain characteristic and transfer curve is denoted enhancement region and between cutoff and IDSS depression region. Configuration of the P-channel depletion mode MOSFET. The previous analysis applies in principle also to the P-channel MOSFET. The construction of P-channel depletion mode MOSFET is the reverse as shown in the figure beside. An N-type substrate and a P-type channel. The terminals keep the same names, reversing voltage polarities and current directions. In a P-channel device, ID flows from source to drain, entering the source terminals and exiting the drain terminal. The figure beside me shows the drain characteristic for the P-channel depletion MOSFET. VDS have negative values, ID positive values, and VGS the polarities exhibited for the new reference in voltage polarities and the current directions. The drain current increases from cutoff in the positive VGS region, depletion mode, through IDSS. The figure shows the transfer curve for a PMOS. The polarity inversion in VGS and ends in a mirror image of the transfer characteristics. Depletion mode MOSFET symbol. The depletion mode MOSFET Symbols for P channel and N channel are shown below. In these MOSFETs, the arrow symbol represents the type of MOSFET like P type or N type. If the arrow symbol is inside direction, then it is N channel, and if the arrow symbol is outside, then it is P channel. Future trend of device development and applications. To conclude these production challenges, the manufacturers will most likely manufacture MOSFET on 300 mm wafers instead of 200 mm or 150 mm wafers. With larger size wafers, chip makers can produce more chips per wafer effectively, increasing supply. Over the next 5 years, many chip makers will likely follow suit and produce MOSFETs on 300 mm wafers. In few years, the supply of MOSFETs will most likely start catching up to its demand.